I'm so used to ignoring it at this point. Yeah, I know that damned callback,
Well,
right?
yeah. Well, we should get started
Yep, we
with
should get
some
started with
introductions.
some like
Why don't
actual introductions. Yeah.
Why don't you introduce yourself first of all?
Okay. My name is Raf Anzovin. I have been doing rigging related things and sort of promoting rigging technique and animation technique for a very long time. I've been doing this for like about 25 years actually. And recently, although really we've been working on this for a long time. Notional Pipe, a company formed by me, Tagore Smith, and Brian Kendall, working on some technology we had started developing at Ansevin Studio, just released Contour Rig Tools, which is a spline-based rigging system that lets you do all kinds of cool stuff that I'm about to show you. And there's lots of other stuff that we'll be discussing from stuff that's particular to Notional Pipe. I'll also be showing the ephemeral system, probably not today, but certainly on this stream, and we will be streaming every Tuesday. But also general, Maya rigging techniques. We're likely to talk about some, layer deformation techniques along with Contour on this stream and stuff like that. And my partner in crime is Tagore Smith, and Tagore, you should introduce yourself now.
Okay, yeah, I'm Tagore Smith. I'm also a principal in Notional Pipe. I worked at Ansevin Studio for a number of years, and so Contour Rig Tools is something that was kind of Raf's brainchild. It was something he really desired, but working out the algorithms and actually figuring out how to make it work is something that I did along with my colleague Brian Kendall, who is not on this stream, but who is also tremendously important. To our development efforts. And I'm going to kind of be playing the straight man to Raf here a little bit because I've worked a lot on both on the Contour that we're going to be showing here and also the ephemeral tools, which is something that's going to be a product. We've been working out some issues in Maya and we've been making some progress lately. And I think it's pretty likely that we'll have the ephemeral tools out in some commercial version, quite possibly this year.
Yeah, I think
hate to make promises about things because software and we have a
right.
lot going on, but I think it's pretty likely that that'll happen. But I don't rig. I'm not a rigger, and I obviously know something about rigging because I've been working on these tools on and off at least for quite a few years. But I'm not a rigger, so I will be playing the straight man a little bit, asking Raf some questions, some of which I will know the answers to already, and some of which I might not. So I might actually have the chance to learn some things too. And I'll also kind of be watching the chat and relaying questions to Raf as well. So yeah, I think with that, Raf.
Yeah, why don't
get started?
I can get started. So I've decided to start the first character that I'm gonna be rigging on this stream is gonna be this pirate dude, which I actually modeled a very, very long time ago. For a variety of reasons. One is I had him lying around, but also because he's a difficult rigging challenge under normal circumstances, right? He's round, right? Like you sort of imagine like if you do the sort of conventional thing and you just put some joints inside him and try to weight that, you're not likely to get very good results. And so if I was doing this conventionally, I would have to, probably layer a bunch of different kinds of deformation on top of each other. I mean, we're going to be doing some layered deformation anyway, but it's more for tweaking purposes than for like primary deformation purposes, which is a really key aspect of what what we wanted to achieve with Contour. And it's maybe worth before I start doing this, doing like a little preamble about some of the ideas that that make this work. And one of them, and this is how I've started sort of conceptualizing it, is that it's really important to have the right primitive for when you're trying to do something complex like a rig. And the way that I'm using the term primitive, I hope that it makes sense. But basically, like, your conventional idea of a rig is that a joint is your primitive, and everything else the rig does is a special case. And this is really unfortunate, right? This leads to enormous rig complexity. And so having a spline as your primitive, which is essentially what Contour allows for. And of course, spline-based rigging has been around for a long time, but it generally hasn't worked especially well. Like you don't generally see people rigging with like wire deformers. And Contour takes that concept, this concept of like, well, characters are kind of made out of these tube-like shapes, and builds a really really effective algorithm to do so right into the deformer, such that it's pretty easy to do a fairly wide variety of things. So now that I've sort of given that sort of like a preamble, I'm gonna hide a whole bunch of this character because I really only want to look at certain parts for the concept I'm about to show. I'm gonna get rid of his hands too. Actually, I'm gonna get rid of the sash also, actually, because that's something we'll have to deal with. You know, it's a bit of a special case. So we're just gonna look at the torso right now, and I'm going to start drawing some contour bones. Yes, thanks, Maya. I know. I should have fixed that before we started the stream, but whatever. It's benign.
Yeah, and I should mention, if there's anything that's unclear here, if you're watching, feel free to ask in the chat, and we'll address it. It's a little hard to know how much preamble to give because it's a little hard to know how much background people have on what contour is and who we are. Like, if you're coming to the stream without knowing anything about that, I should just mention contour is this tool that we've released for Maya, and as Raf's been saying, I mean, it has actually quite a lot of features, but at its heart, it is a spline-based deformation system. And the basic idea behind it is that it gives you pretty good deformation of most shapes right out of the box. And one of the nice things about it is that the splines really cover large areas of deformation. So you have to paint weights between the splines. But the splines themselves are single influences, right? There's no weighting along the spline. So the spline is controlling a great deal of the deformation that you would normally be having to sort of paint between a whole bunch of influences if you were using joints for them. Right. So I just mentioned that.
Yeah, so like let me show that right off the bat, right? You know, might as well start right in with this spine. The arms are going to be all weird because they're like way out to the side here. We'll add some bones to them in a second. But going to bind it to there, going to bind it to the belt, going to bind it to this like shirt piece thingy. And so what we have here now is something that, I haven't painted any weights, but the spline-based deformation here, let me show this, handles twist, sort of as a central aspect of what the deformer does. So the two really notable things right off the bat. I'm just going to hide the radius indicators, because otherwise it's just a little visually confusing. But the two things to note right off the bat is it's twisting the area between these two joints automatically as part of what the deformer does, and B, it does this sort of mesh spreading. So if I tilt the character way over, again, ignore the arms for the moment, they're going to get their own bones, but we're just looking at the body, you're going to get pretty perfect deformation, and that's a natural consequence of the deformer. It's not something that I literally didn't do anything. I drew some bones in, and that's it. And you have some controls. Yeah.
It's maybe worth taking a little bit of a look just at the anatomy of what is there on the screen.
Yep.
Right. So there is a spline here, and you can see there's some shapes being drawn. And at the very bottom, there's what we call a joint socket, which is that sort of empty partial cube shape, which basically roots each of the splines, gives it a base transform and a base buffer. And then you can see that there are some joints, and right now all we have is joints in the spline. And they pretty much control the shape of the spline at the moment. So, and as I said, it's a single influence.
Yep. I have now added a bone CV. So you can see that it really is a spline, and it really does deform the mesh in this spline-like way. And to reiterate what Tagore said, we really hope this to be we're kind of demoing a thing, but we want this to be like a pretty interactive thing. So you guys should definitely ask questions about what we're doing, and we'll sort of cater. I'm gonna sort of cater what I'm doing a little bit to whatever people want to know. Actually, this is definitely something I hope is guided a little bit by audience participation. So please ask whatever questions you want to ask, and we will respond. So what I just showed was treating each of these elements. So this is a joint, and this is a bone CV, and they act a little bit differently, but they both control the spline. And just sort of pulling them around sort of willy-nilly. You can also set up a variety of fairly simple control structures. So I'm going to add an aim handle. I'm going to scale that up. It's just actually, you know what? I'm going to make it an actual. I'm going to make it an actual circle because otherwise it's going to be hard to select.
Yeah, I think it might be worth sort of narrating in detail what you're doing.
Yeah. Okay. So here's what I'm doing. You're
reproduce
right. It. Yeah. I'm so used to doing this stuff myself and just being, oh yeah, I'm doing this and doing that, right? It is sort of important to narrate what I'm doing. So when I'm creating an aim handle, a contour has its own like IK handle and aim handle that are things that you can attach to these to joints and bones in a chain. Um, and they have a variety of nice features. They do pretty much act the way you'd expect. The aim handle by default stretches, which is why I'm using it. You'll note that it's stretching the bone CV along with it, which is pretty much like well, actually it doesn't rotate yet. One second. I'm also going to set up, and this is basically equivalent to an orient constraint. It's not actually an orient constraint, but it is very, very similar. Creating a contour orient, and now it's going to act like this is basically a Schleifer spine, right? Which sort of falls out of the behavior of the spline to begin with. And in the middle, like this is going to be, this control, this bone CV. Is going to be something that you can animate. And one of the other principles, one of the things that we wanted to create here is the idea that you're not necessarily forced into having complex control structures. So the conventional concept of how rigging was supposed to work, like if you imagine sort of like in the 90s when Maya rigging, Maya was first being written, when rigging was first being sort of conceived of. People, and you can sort of see that this is what was intended. The idea was, well, you draw some bones inside your character, and then you add an IK handle, maybe if you need to, and like that's your rig. People really didn't have the concept of a control rig didn't quite exist yet. I mean, actually, that's not quite true. It kind of did in some places, but there generally was this idea that rigging was supposed to be a lot simpler than it has turned out to be. And the reason for that is that what people actually needed out of rigging was entirely different from what the base rigging tools that you'd find in Maya or another DCC tool allow, right? You have this idea that you have some joints, but the control structures that actually give animators good control over those joints is not a base feature of the application. It's a thing that people built on top, like special case, like bashing a bunch of nodes together. Sometimes like really weird stuff, like you're actually about to see me do some stuff where I'm going to use a shading node as a math node in Maya, because that's actually how math nodes used to work in Maya before they added some custom math nodes. And so you have all this stuff that's just sort of like was never really considered. The applications weren't written to support the complexity of a high level rig that would do, would allow for stuff like this. And that was, we've paid the cost in that in just like really runaway rig complexity and complexity of creating rigs. So one of the concepts that we're trying to get at here is the idea that, you're certainly free to do fairly complex control rigs, and there's a lot of cases where that probably is what you want to do. But you also can sort of draw a bone, add, you have a couple of tools to like add an aim handle or an IK handle, and that does actually make you a pretty effective rig that you can just straight up use. And so that's one of the concepts that this allows for. The idea is that rigging should be a lot simpler than it is, and that goes back to the idea of not having the right primitive. Like part of the reason why rigging is so complicated is because we have joints and transforms as the as sort of the primitive. In terms of just to answer, like I was looking over there, I know Tagore, you were kind of going to be monitoring that, but I happened to notice that Carolis Galkus, I hope I pronounced your name correctly, was asking, is there a keep length option? Actually, so there is, in the sense that this rigging that produces the stretch is something you can turn off. So one of the really nice things about these bones, actually, is that they have a concept of length and stretch. And you can override that length or stretch. So right now, I have a blend on the aim handle that, now this is overriding every aspect of it. So I can just turn off the aim handle with this blend. Very similar to an IKFK type blend, right? But I could also do that individually. So what that's actually doing is, what the aim handle's actually doing, is it's piping information into override blend and override stretch. Override blend is how much the override is happening. Override stretch is the actual stretch value being produced by the aim handle. We don't.
So, Raph, it might be worth pointing something out here, which is that in Maya, bones are something of a fiction.
Yes.
Right? What you have is joints. Okay.
That is a really good point. Yeah.
It's probably important to point out here that we actually do have bones.
That's right.
So there are joints, but there are also nodes in the seam between the joints in the hierarchy. Usually, you can take them out of the hierarchy.
Yeah, you're not bound to it, but it's a very, very useful thing. And what that means is that the bone actually has a canonical length, right? Like Maya joints don't have a canonical length. Maya joints are
so the thing about the bones is they're transforms as well. they buffer the joints.
Right.
And the length basically offsets the joint. That's what creates the space between the joints, essentially, if the joints are zeroed in local space.
Indeed. So if I wanted to not have this stretch happen, I could just, I mean, actually the simplest thing is I break the connection to override blend and I turn that off. And now I've got something that's an aim, but it doesn't stretch. So it's not so much of having an option to keep length, it's that, well, you just turn that off, right? You don't need to do it. Now, that is something that it does automatically, like it hooks up the length for you. It hooks up the stretch for you. It actually doesn't hook up the length. That's actually very important. Because one really important element here is that this length value doesn't change unless you're actually changing the proportions of your rig. And this is one of the things that makes it much easier to reason about contour rigs as opposed to, conventional Maya rigs, is that Maya joints are sort of, like as Tagore says, they're a fiction, right? They're just transform nodes. Right, and the length of a bone is just how far away is one joint from the other. And there's nothing in the joint that's stored, I mean, the bind pose does, but there's nothing in the joint itself that has any concept of there's some particular distance that's the distance, right? Like, that is my default bind pose distance from the joint before me. So if you turn stretch off, could we slide along the spine, or would it always go to the start? I'm not quite sure I understand the question. Maybe reword it. So, a spline. Oh, that does make more sense. Yeah, I mean, basically, it's going to act like this, right? It's basically an aim at this point. So it's like it's always going to keep that joint here. I mean, it's literally controlling this joint's rotation override to aim at the aim handle. So yeah, you can slide it up and down. Usually, stretch is actually what I want, because usually, I'm often, personally, I'm really creating stretchy rigs pretty much all the time, right? But of course, lots of rigs aren't, and contour works very effectively for like more conventional rigs too. You're not obligated to stretch things. But one of the nice things that you get from this is that everything is inherently stretchy. So if you need stretchy features, they are inherently available to you at all times, whether or not you anticipated needing them beforehand. So a lot of what this means in a lot of cases is if I've got, can I move my hand till it shows up? It's the latency screwing up. I want to see if you can see my hand. Maybe you can't. All right, never mind. I'm going to pretend that didn't happen.
Still waiting on the hand.
Yeah. Anyway,
there it is.
There it is. Wow, the latency is super long.
We have a lot of latency here, which is kind of unfortunate.
It is actually.
We'll have to look into that, but let's proceed.
Yes, but anyway, the idea is you've got fingers, and of course, one of the really common issues that you encounter with fingers. Actually, let me load up the contour. Let me load up the as an example. I'm just going to save this, and I'm going to load up the dude, actually, I'm going to undo this thing that I did with the stretch first, because I actually do want that back. There we go. Then I'm going to save it. Then I'm going to load up the contour man, because that's a good example for finger purposes of showing some finger stuff. So here's one of our example rigs. This is Contour Man. And one of the really common examples here is, I've got all these fingers and I bend them into a fist, say. Yeah.
And I should mention, this rig is available on our website.
That's right.
And you can run it using, so there's a demo version of Contour that has a 30-day trial that you can use to actually rig with. But Contour is free to animate with. You don't need the paid plugin. So in fact, you can animate with this rig with just the free version of
That's
it
right.
as well.
And it's freely available. You can use it for anything you want. So here's a really classic issue that you encounter with hands all the time, right? If you didn't model it in a really good set of proportions for being able to like close and clench the hands and do stuff with it, it gets really awkward. Right, you end up, and there's a huge amount of back and forth that you often get with modelers, where you're like, I clenched the hand and I discovered that the proportions don't really look that good, and now I'm going to have to go back to modeling. They're going to have to change the proportions outside of that context. It's a huge pain. So one of the things that is really nice here is that I can do this. And that is not a feature that I had to build into the rig. That's just something that any contour chain can do that. So I have the ability to like reshape this, if I want to be real precise about my clenched, pose, I can really easily like reshape this whole thing and like have very close control over this. And it really makes it a lot easier to avoid situations where you backed yourself into a corner by modeling decisions that got made earlier on in the process. Also, I just think that it's really nice to look at this deformation. This is precisely what Contour gives you with no weight painting. Let me actually show you what the weights on this look like. And this is the Contour weight painting interface, which looks very, very similar to the Maya one.
Yep. And I'll mention that there's a clarification in the comments, Raf, but why don't you finish?
Oh, okay, yeah, and I'll take a look at that. But this is the weights for the pinky, right? You know, so all of this deformation is coming from the Contour spline, but you get this really nice thing where it's not like ugly and weird, and even though no weights were painted. And yeah, I mean, fingers are just drastically easier that way. It's that thing about finding the right primitive for the task that you're actually attempting to do. Anyway, let me take a look at the clarification. Yes. So to read it. So here I'm trying to get good about doing stream things, and one of the things I guess you have to do is you always have to read the comment, because of course other people who are watching it later on may not see the comment. So anyway, the comment is I meant the geo. If we had a snake, could we use Contour to make a path and then slide it along, or would we make our own Maya setup to drive Contour along a curve or similar? So you'd probably do the latter. Right, you could bend your snake around in various ways, but if you wanted to animate it along a spline, you'd probably drive the various controls, probably bone CVs, along a spline. And there's a variety of reasons for that. And one of the reasons is for performance, because a rebind in Contour, you can do it, but it is a performance hit. And so, for instance, one of the things I'm about to show is you usually stack deformers on top of Contour deformation rather than underneath it. So if you had the idea of like, oh, you've got this big long spline and you're driving your snake through it, right? That snake's vertices would have to find the closest point on that curve to bind every single frame. That's a performance hit. So we don't generally do that.
Yeah, although it is worth noting, Raf, that we did do a fair bit of optimization on the bind process a little while ago. And if you don't have a great deal of geometry, you can rebind pretty close to interactively these days.
Yeah, it's true.
But if you have a lot of geometry, the binding process is still kind of expensive. And one of the things that we would kind of like to do, but that is a little bit difficult given Maya's architecture, is to push a lot of Contour onto the GPU eventually. But that's something we haven't done, and there are some challenges for. If we could do that, I think we could get really, really good interactive binding. Yeah. But we don't have a timeline on that. Let's put it that way.
I mean, our system is currently not on the GPU. It's actually astonishingly fast given that it's not on the GPU. It's highly optimized, and a lot of that has to do with the fact that it subsumes a lot of the complexity that normally goes into a rig into itself. So that even though it's not as fast as it could be on the GPU, it's still, like, compared to a comparable rig that does similar types of features, it's actually very fast, and it parallelizes very well, and that's a big part of the reason.
Okay, so perhaps though, going back to the pirate.
Yeah, let's go back to the pirate. So I think talking about these bones, here's something that would be nice to show next. Actually, I'm going to show how you can get some data out of these bones to use elsewhere in the rig, or along the same part of the rig. That's really useful. So one of the things I do all the time is to set up like basic stretch and squash type things around shapes like this, right? Often on a character's torso. And in this case, it's a pretty easy thing to do. Let me just grab this bone. There's a bunch of data that you can get out of the bone. That's very helpful. And in this case, the thing that really matters is a thing called stretch out. And this is different from the stretch or override stretch attribute, because what override stretch allows you to do is have multiple possible stretch attributes, the one that the bone itself has, and then one that might be coming in from an aim handle or an IK handle. But ultimately, you want to know, for purposes of squash and stretch type deformation, you want to know specifically what this stretch out itself is. That is to say, what's the product of anything that might be making this bone stretch? What is the bone's real stretch? Keeping in mind, again, that stretch is a multiplier on length. So in the bone's canonical length, stretch out will be 1, which is exactly what you want for being able to do things like figure out how much squash and stretch you could do. So like here's a useful thing. I'm gonna create a multiply divide node. Classic example of shading nodes actually being math nodes for some reason. Sorry, I've just got like a lot of windows here, and I'm trying to keep them all on the same monitor because you can't see my other monitor. But basically, if I divide one by this value, I'll get sort of an inverted value that I can use to drive bulge. I haven't discussed this yet, but one of the things you can do with these splines is you can actually bulge the area around the spline, around the a given bone CV or joint. I'm going to grab the bone CV, and I'm going to plug the result of this into bulge. Now, this is like way too strong, right? So this is like, oh, it gets really like, yeah, this is not that useful. So I am going to, again, using shading nodes, I'm going to use a blend colors and say the second value, the value I'm blending it with, is going to be 1, which is, white. And I'm going to output that to... Yeah, it doesn't want to let me do that because it's already plugged in. One second. I'm just going to make this more clear. There we go. I often do this stuff by the command line, actually, because it can be a little irritating. And I probably will show later on, I'll probably do some Python scripting because it's, often an extremely useful thing to do. So that's like a lot less, weird and broken. And what I usually do is take the joints on either side and give them a little bit too, to sort of blend it in and make it nicer. I probably don't need to do that. I just need to do this. There we go. So that often, like when you're moving your character around, when you're animating your character, and you could publish, like you could build something in here that would just blend it on and off, or have a bit of control over how it actually functions. But this gives you some really nice sort of automatic squash and stretch.
Right. And of course, it's worth pointing out at the moment that we have the arms.
Right. The arm deformation looks all weird because we haven't put any actual bones in the arms. But this is a pretty common approach to using like a bone stretch to drive other aspects of the rig. And there's other stuff you might want to drive, like among other things, it's sometimes helpful to drive colors and things in the rig to tell you how far you're stretching and stuff like that. So when you're going off model. I'm a big fan of going off model, but it is nice to know when you are. And so to reiterate, in case this wasn't clear, I mean, I'm kind of going through this a little bit quickly because it's sort of what I would do naturally. And if any of it is unclear, like really do feel free to just ask right in the just ask in the chat, and we'll definitely address it. But I'm basically taking the stretch out and dividing 1 by it to get a bulge value, and then I'm just sort of stepping that down by blending it with 1. And then blending it with 1, stepping that down further for the joints at the top and bottom, so that I get something where the most stretch is happening right around this bone CV here, but there's a little bit of stretch happening at the top joint and the bottom joint too, to sort of blend it in so it isn't so abrupt. I think probably,
right, and to reiterate. Yeah. This is being controlled. There's a bulge attribute basically on each of the CVs of the spline.
And the bulge is what's
joints
and
bone CVs. Yeah, joints and bone CVs are both CVs of the spline. They differ a little bit in that an area of spline between joints will always be straight, right? So when you want curves, you add a bone CV, and that's what produces curves in the spline.
Right. And what the splines are actually doing, this will become a lot more. Oh, right, this is controlled, so I can't do that right now. This will become a lot more evident. Is that when you rotate this, what it's actually doing is creating a little bend inside here, and that's why you can get good results on arms and stuff that aren't such broad, category, just a broad deformation like we have in the body. And actually, so the next thing I should do is arms actually, and that'll show a little bit of how weight painting works too.
It's probably also worth noting, I'll just toot our horn a little bit here, that it's taken us a little while to go through this because we've been talking about it and we switched to another scene. But really this is about 3 minutes of work, really, right,
Yeah,
Raph?
this is very, very easy. This kind of thing is so easy to do.
And it's basically like a Schleifer spine with some built-in squash and stretch. It's doing a lot for the amount of work that has been
Right.
put into it, right?
And that
We
that,
haven't painted any weights yet.
that also goes a lot to the performance question, which is to say, the algorithm here is certainly slower than linear blend, by quite a bit, but it's subsuming so much stuff that your rig would otherwise have to calculate and doing it so much more performantly than your rig normally does, that it ends up actually being faster in the long run in many cases. Let's just see. Also, I will just note, also to toot our own harm, that our bone draw tool is actually very nice. You can pull bones around in different directions in a nice way, and it will handle it properly. Maya kind of doesn't very much. I'm just kind of trying to arrange this so it's got a little bend, because you still need that for IK as normal, right? As you'd expect with IK. And you can also roll the bones. I think I'm just going to leave it at default now. And I'm going to control this one's radius to be more or less the radius of the arm. Now, one thing that's maybe worth noting about this, actually, is that this isn't... I mean, this will work fine, but it's not actually the most ideal circumstance you could have. And the reason for that is that there's a bit more of a bend here than is most ideal. Which is that because you're binding to a spline, and because to do that, it's like finding what part of the spline the mesh ought to bind to. Having significant acute bends is not actually... often within the same spline. I mean, you can certainly have multiple splines that you can do whatever, and that's what we do for feet. But having a really acute bend, and this one's probably fine, but having a really acute bend is sometimes troublesome. And so, had I modeled this character at specifically for Contour, I probably would have modeled... I mean, I still would have done an A pose, because I find A poses to generally be really superior to T poses. But I would have probably made the arms a little bit more out this way. But it's really okay. I don't think it's going to be an issue in this case. I'm gonna mirror it. I'm not really naming anything as I go, because this is just sort of for demonstration purposes. I would in reality. Although sometimes I won't. That's actually a thing I have a rant for. Maybe I should do that sometime. Naming in rigs matters, but it doesn't matter as much as a lot of people seem to think that it does. All right, let me just...
Yeah. So that's, there are a lot of things in Contour that you need to use our tools for.
That's right.
So we do have our own mirror tool that mirrors chains. We have our own duplicate tools, and it does a little bit of automatic naming there for you too.
Yeah. A good point to make. I wasn't thinking about that. But of course, I reflexively just used our tools to mirror, because that's what I normally do. And people were maybe wondering what was actually going on there. So it is a good lesson for me. I'm not used to doing this in front of people. Anyway, I am going to add these influences. By default, they do not do anything, but they will in a minute. Here's where we actually will need to do some weight painting. So right now, the whole thing's weighted to this spline, the spine spline. I'm going to select some things. Brian really did this, and he did a really good job sort of making sure that it has basically the same features that Maya's does.
Right. It's our own weight painting tool, but it does very much mirror Maya's. So it should be very, very familiar.
Right,
if you know
exactly.
How to paint
we wanted to make sure that people weren't going to be too confused by it, that it would basically do what you'd expect.
And it's also worth noting what Raph just did, which is he added influences to a deformer.
Right.
So you basically have a single deformer for a mesh, but you can add influences to that deformer.
Right.
And each of the influences, we also sometimes call them deform fields, because they basically create a field in space that maps points onto other points, essentially. So we pretty much use the term deform field almost interchangeably, depending on context.
If you want to think about what Contour does, it's binding to this deform field, which is something that the spline generates. I'm just kind of doing something really dumb here, so I can sort of get it in vaguely in place, and I'm then gonna fix the weights right in this area. But basically, you do get to do this really nice thing of being like, oh yeah, the whole arm is basically one thing. Let me actually just show you how that looks real quick, because it looks like this. That is the default deformation. So, like, for a lot of purposes, and for this character perhaps, it is essentially correct, like, by default, right? And not for every character, it isn't necessarily. There's plenty of characters where you want to do more refinement. There's a variety of ways of doing that. One is you can control the by using this radius. So that's where I was talking about basically what this radius means. It's the amount of bend in the spline that's happening at that joint. And so you have a fair amount of high level control, and you can also like layer PSDs over it to get really specific art directable shapes and all kinds of other stuff. But what's particularly nice, and this is especially true for fingers, as we were kind of looking at before, is that like really for fingers, like I have not encountered a situation in which I needed to do anything special. Like they pretty much just look good, and they look as good as you need them to. For elbows and shoulders, I do often end up doing a bit more refinement and maybe do some PSDs for art directability. But for a lot of circumstances, it's really just like it's done. Like you put a joint in and it works. Assuming you get the radius appropriate, because like that's something that's maybe worth noting here. You may have noticed me adjusting the radius before bind. You can adjust it after bind too. Like if I change the radius here, you're going to see that the deformation changes a lot. And if I go all the way down to the bottom, you'll see that it basically now it's a wire deformer, and it kind of looks kind of crappy. What that's really doing is it's creating a radius at which the deformation will look best, and it's pretty forgiving. So like this arm is pretty much all the same width. Lots of arms aren't. It still works pretty well. There are some really extreme cases where I might use multiple joint chains, so that I can have paint towards a different radius if like you've got like this cartoony arm that like narrows from being really, really thick down to being like a tiny little thing at the wrist, say. But for most things, you don't really need to worry about it too much.
Yeah, it takes a pretty, there has to be a pretty extreme difference. It needs to be several times pretty much before it even begins to become an issue.
Yeah. I mean, and it's also like, depends on like what you want to do art direction wise and like a lot of other questions. But most of the time, this pretty much just works. I'm going to sort of blend this in a little bit. This is just sort of your normal thing. I should also note about this mesh, actually.
We have another question here about self-collisions.
Oh, sure. Let me address that question. So in terms of like actual self-collision, so Contour is pretty good.
Might want to read the question.
Of course. Again, like not used to streaming. So here's the question. From Matthias Roivik. I hope I'm pronouncing your name correctly. I'm not good at pronouncing people's names correctly, so please correct me if I'm not. But I don't think I've seen anything about self-collisions, like in that elbow area when you want that. Is that something you want Contour to do, or would that be out of scope for the tool? So Contour does not actively prevent self-collision specifically. It defers it, in a sense. So if we look at what this arm is doing, you get like if you think about this being like a wire deformer, right? You get total self-collision at this point, right? You plenty of it. Here you don't get it. Now you do get it eventually, right? Now it's self-colliding. And Contour won't, and given the way it works, it wouldn't really be reasonable for it to prevent all self-collision. What it does is defers it until much later, sort of in the rotation, as it were, by spreading the mesh around nicely. And so what that means is if you have a case where this is a problem, and it may or may not be, like it depends on how thick your arm is, it depends on like what your actual considerations are, for a lot of characters, this actually is maybe fine, right? It depends on what you're doing, right? But if I wanted to, I would use a PSD to like very specifically control something at this point. So that is a bit like preventing all self-collision or doing some kind of like actual like, soft body or something to actually collide. That is out of scope for Contour. You can certainly do that stuff on top of Contour, but what Contour does that's very nice is, if you're relying, for instance, a lot on PSDs, you'll tend to get things where it's like, okay, well, you're already need to use them at this point, right? You already need to deal with PSD related issues like already here, and that tends to make enormous like if that's how you're relying on trying to prevent collision, you end up relying on enormous numbers of PSDs, and this just becomes difficult to handle, right? Whereas here, like, yeah, you get self collision, but you don't get it till you're pretty well in there. So So yeah, it is something you sometimes have to deal with, and you sometimes layer some deformation on top to deal with that. But you generally, like, because you're adding that on top of a very stable basis that doesn't show that many issues, like you only get that issue when you push it really far. It's much easier to deal with in my experience than it is under most other conditions.
Yeah, and I'll just add to that. Yeah, I would say that it is definitely out of scope for what Rig Tools does. But what Rig Tools is really, it's Rig Tools is not actually very concerned with the surface itself,
Yeah.
but it is concerned about basically warping space in such a way that you get very aesthetic shapes out of things when you deform them. And so, yeah, we defer other things. I mean, that's really what we do. And then if you need to do some other things, typically another tool will go on top of that.
Now, for this lapel area here, I might actually defer dealing with this just now because like this would be like it's some weight painting and I want to get onto other things. There's a number of ways that you might deal with this. The simple way is you'd paint some weights from the arm onto it. That would work fine. I don't know that that's actually what I would do in this circumstance though, because what that would tend to produce is a case where then it gets like really long and stretched out when you bring the arm down. I have to like fix a little bit in there too. Like this is also a little bit. Here's where you get to the weight painting part where like. Yeah, I mean, weight painting is as obnoxious as it ever is. You just have to do a lot less of it than you normally have to do. Oh, also, I will just note this really nice thing. Watch this. So you guys have potentially used the smooth tool where you have cases like this where you've got something fully weighted to one influence and probably watched your weights get like ridiculous values. Like that's often what happens. Rig Tools doesn't do that. What it will do is simply, like if I do this, it's going to simply refuse to change it. It won't try to normalize weights that don't make sense to normalize because there's nothing to normalize them with. Which is, in my view, like tremendously, it's much better than what Maya normally does with that, where it will try to do so and probably come up with a weird answer that you didn't actually want.
Yeah, unfortunately, I will just mention, although there's probably not much we can do about it, but the video quality has dropped really substantially.
That's really unfortunate.
Yeah.
Well, I hope that I don't know. I don't know what streamers normally do about stuff like that because this is my first time doing this.
Well, we may have to think about it, and I hope it's not your internet connection because that, of course, would be a little bit difficult to do too much about, perhaps.
That's true, but I don't think that it is. I mean, well, my internet connection normally is pretty fast. I mean, we maybe should do some tests, right? Maybe afterwards to see.
But I don't think there's much we can do about it now. So
no, there's nothing we can do about it right now. So.
But be aware that unfortunately this is pretty blocky at the moment.
I'm just going to reset. I'll also note, we were talking about how the bones buffer the joints. So, I'm doing what you'd normally do in a rig, which is to reset things to 0 when you want them to go back to their bind posts, right? But that's sort of something that's actually sort of naturally there because each of these bones buffers the next joint. After the moment you've drawn this bone chain, everything is properly buffered, and I can always just have it go back to bind post by zeroing things out. Let's see. I'm actually also going to get rid of these radius indicators because they just they're important for when you're choosing your radius, but then they just get a little visually confusing. So we have a button to just turn them off. Anyway, I am going to mirror my weights. Which again, we have our own mirror weights tool. It pretty much works the way the Maya's does, so it should be pretty easy to deal with. So now that we have actually added some arms, we are no longer getting. Yeah, I might tone that down a little, even so. But anyway, the point is, we're no longer getting like weird arm deformation because now we have the arms actually doing something that isn't weird.
Okay. By the way, the quality might be specific to me because people are saying in the comments that they're seeing it fine. So that's great.
Okay.
That's good.
Well, that's good.
Thank you.
Yeah.
Thank you very much for letting us know.
Let's see. So, what is the next thing that I should do? I think so. There's some stuff I want to get onto in terms of adding tweaker controls on top of a contour.
You might show inherent twist. You might show inherent.
Oh, you know what? I should show inherent twist. That is a very good idea because inherent twist is a really cool feature and it's easy to show. So here's a classic rigging problem. That looks really bad, doesn't it? Right? Here's your classic like bad shoulder twist. The whole system we have for managing twist down the spline is actually really nice. So I'm going to turn on inherent twist, and what inherent twist does is to hold, like, basically it looks up the spline at the control, a control immediately before it, the joint immediately before it, and it figures out what twist it ought to have at this point in the spline from there. Oh, also you saw me just translate the thing and have everything work. That again falls out of the fact that this is a spline, and therefore if I move one of the CVs, it does spline things, right?
And you might want to just show twist down the spline too.
Yeah,
That's
actually,
a really
let me just like
rituals. And Jacob English is asking how do they twist? And
how do
that's
they
a good
twist?
question.
So they it has a bunch of internal, like that's something that the deformer does internally. So that's actually a really good point that I'm glad was brought up because it's something I didn't really talk about until now. But managing twist is another one. Like I was talking about stuff where it's like, oh, you have this big complicated system, and one of the reason why Contour is often very performant is that it takes a bunch of complicated systems that otherwise need to be in the node graph of your rig, and the deformer just does that. And twist is actually a really good example of that. So basically, each one of these joints, in addition to having a separate twist value, actually, you can, I mean, the geometry's not going to support this, right? But, right. You can theoretically twist as much as you want, but it also has twists that it figures out from the world space rotation of any of these joints.
Yeah, so just to clarify that, there are a couple of types of twist that we have, and one of them just comes from the joints, right? And it just naturally falls out of the joints. If you move the joints, you get twist. But there's basically, you can and bone CVs are a little bit different from joints, and they don't by default add to the twist, but you can turn that on so that the bone CV's frame also controls twist.
Right, let me add some here.
It's an attribute on them. But there's also another attribute on each of these influences, not influences, but each of the CVs of the spline that layers additional twist on top of it. And so the natural twist of the joints can only go up to 180 degrees. But the twist that you can overlay onto it, you can, if you have the geometry to support it, you can add an arbitrary amount of twist, and it'll never candy wrapper if you have enough geometry. Now, right. Obviously, if you can add 720 degrees of twist, you're going to need a lot of geometry to support that. But it does mathematically fall out correctly when you do that.
Yep. Now, here's one thing to just note here. So note that when I'm twisting this, you can see like a little, see that going on over there. Sometimes that doesn't really matter. What that's actually coming from is the fact that this twist is spline. And because we need the twist at a given joint, or a given CV, basically, to actually match the actual twist value that you actually have, right? That seems pretty important. As a result, we do essentially the equivalent of, it's a spline. When we do spline twist, that's a spline that interpolates its control points. What do they call that? It's not a... what's the technical term for that? Like when you have a spline that actually...
It's an interpolating spline.
It's interpolating spline. Okay, yeah. But, of course...
It interpolates as
point. Yeah, exactly. The consequence of an interpolating spline, as is always true, right? If you want it to be smooth, is overshoot. And so what you're seeing there, you don't see it, like, it's not always a problem, but, like, yeah, what you're seeing there is actually spline overshoot. And for a lot of characters, it actually doesn't matter that much, because you're not usually twisting these things purely in isolation. You've got a character that's really transforming its pose. But sometimes it isn't great to have it do that, and you have the linear option too. And linear actually often also produces perfectly good twisting. So it's not really necessary to use spline, and sometimes I do and sometimes I don't. It just sort of depends on what looks good. If you are ever encountering issues where the spline overshoot and the twist looks weird, like linear will solve that issue for you. And especially when you have a case here where you've got something where you're not, you have a relatively low res mesh. Like if one of the things that I should mention about this and about this mesh is that it is lower res. I mean, it's not ridiculously low res, but it's lower res than a lot of meshes that you see people doing with animation are. And that's, to an extent, a personal preference. There's a lot of things that I think lower res meshes are good for, not modeling wise, right? Like you don't sculpt a mesh at this resolution, you topo it at this resolution, but that has a variety of sort of nice effects. You don't need it to be this low. I mean, you can use rig tools perfectly well with meshes of much higher density. But what it does do is it means that certain things, like the way that this is a linear twist, like work out fine, right? That helps to soften some of that stuff. Otherwise, you might lean on spline twist a little bit more. I mean, it's usually not really an issue either way. I'm just going to set this stuff back to default. I'm also going to bug this. Like this thing bugs me now. Like this is your classic. This is like the one. Like this is I think a perfect example of why weight painting has always been such a pain, right? Like the one place where I actually am painting weights, that's the area where I have to go back several times and be like, oh, I'm going to tweak it a little bit, right? Weight painting is an awkward and I think not a good concept, right? It's something that we kind of got stuck with because of, well, these problems of like, what primitive do we use for rigging? Well, it's just joints and they're just transforms. And therefore, weight painting became something that you had to do a lot of, and it's always been a really ugly way of controlling deformation, in my opinion. Not an opinion that everyone shares. I do know some people who really love weight painting. If Charles Wardlaw is watching this, he can tell you all about that. But my view is that linear blend weights are the wrong choice for a wide variety of things. Not for everything, right? But for a wide variety of things, they're the wrong choice as the base way of the default way of deforming characters, right? Because they by themselves, right? Unless you do a lot of work on them, usually involving adding a bunch of extra influences to control things well, you're not going to get good results. Like, good results don't fall out of the technique. And that has a lot to do with again, this idea of like choosing the right primitive for the task you're trying to solve.
Right. I mean, it's worth noting that the solution that Rig Tools comes up with, like down a spline when you're within a spline, not when you're painting between them, that solution isn't in the solution space of linear blend weighting, right, unless you basically get to a point where you have one influence per vertex.
Yep,
at which point,
right, like, what were you really doing? Right, exactly. So, like, that's a situation where you're like, when you have situations like that, you usually end up, you either approximate it with like a whole bunch of extra influences, or you use really extensive PSDs, and either of those things is both, they're both brittle, and they're very very labor intensive, right? And both of those things I think are sort of fall out of using the wrong primitive. So now this is nicer. And so what this tends to be in situations like this, looking at the deformation of this arm, is that you're getting a lot from the contour spline deformation, and it's these areas of crossover where you end up spending the most time either with weight painting, or in some cases, I'll use things like Delta Mush right under here to solve some issues. But it's a much less extensive than you'd need to do in any sort of conventional rig, because you're doing it on a stable basis, I guess is a good way of describing it. So we talked a little bit about
But you were also going to show Inherit Twist. That was
right. No, I think I did show Inherit Twist.
Oh, did you?
Right, yeah, because I already turned it on. And so what Inherit Twist is about is, like, generally speaking, it looks at the frame of this joint and tries to twist up to the frame of the next joint, right? That's what it does. It reaches for the next one. But sometimes doing that has weird consequences. Especially, like, let me turn Inherit Twist off, especially on shoulders, right? This is your classic ugly shoulder twisting, right? That looks awful, and we don't want it. And I'm probably saying something that a lot of people on this stream like are very well aware of already, but the classic way to deal with that is like, you have one joint chain that actually figures out your IK, or probably it's actually a blend of IK and FK, and then like you've got an underlying joint chain that takes the matrices of that joint chain and calculates twist from them, and like distributes that among a number of joints, and like there's a whole process to that, right? And here the idea was you should be able to just do this with one joint chain. Just draw a joint chain in. You shouldn't need to have multiple hierarchies to be able to do something that we basically need to do every single rig. There is no rig where twist management isn't a problem that you have to solve, right? And whether you solve it with some sort of auto rigger so you don't think about it or not, it's a problem that has to be built into your rig. So if you build it into the deformer, that makes your life a lot easier.
All right, so moving on.
Let me just I did just note that Jacob English also asked, how do you handle gimbal? Right. So in terms of animation, gimbal doesn't gimbal lock, and again, like, I'll just mention this because again, I expect that anybody watching this probably knows what gimbal lock is, but just in case it's someone doesn't, it's basically when you have Euler angles basically take various rotations, X, Y, Z, and compose them together, and at some point you're going to do a rotation that's going to make two of those things line up, and then you're in trouble if you want to animate them directly. So Contour, the ephemeral system, handles gimbal perfectly, which is to say removes it completely. But we're just talking about Contour right now. And so what Contour does is it removes gimbal considerations from deformation. So the calculations that Contour is doing under the hood do not use Euler angles. And in fact, it's my view that calculations done internal to a rig, not exposed to the animator, should never use Euler angle for anything, right? Euler angles are evil, right? They're terrible. The only reason we still use them, and all of the problems that come with them, such as gimbal lock, is that there's something animators can think about, and animators can't really think about quaternions if you want to actually look at them in a graph editor, right? And that's the only reason why we ever use Euler angles for any reason at all. But there's really no reason for us to ever use them internally to a rig. So the issues that you would normally encounter as an animator haven't changed, right? Yeah, I mean, you can gimbal lock this control, just like you can any other, or this joint, right, which can also be an animation control if you want to expose it to the animator. Like nothing's changed in that regard. However, in terms of all of the math that we're doing internally to how the deformer works, there's no Euler angles here anywhere. So gimbal just isn't a thing, right? Gimbal never comes up in terms of like how the twist actually functions. Now, it is true that if you twist the twist that you figure out from transformation, as opposed to the twist that you apply directly, which can be like whatever you want, right? This will flip past 180 degrees because it's trying to take the shortest path. And generally speaking, taking the shortest path is the right thing to do. Usually when you have arms and, you don't normally actually rotate them back such that this actually becomes an issue, even with fairly cartoony arms. That doesn't mean that it's an issue that you can't get at all ever, because you definitely can. There are specialized cases where you could have a rig where you could actually push it past 180 degrees and get a snap. And that's something where if you wanted a system that handled that properly, we're not doing that internally to the deformer, but you could create a system that drove the twist attribute.
Right. There is
and
this.
That lets
this
you twist as much as you want.
Offset twist that allows you to do what you want. And you can also, you could use it essentially if I imagine there are circumstances, you can tell me this, Raf, because I'm not a rigger, but where you could rig things up that even basically handled for specific cases this stuff by using it as an offset.
That's right. Yeah, no, you absolutely could. Like, this is something that isn't built in to the system because it's something that we don't actually encounter all the time, right? And our biggest focus is how do we solve the problems people encounter constantly, right? But it is a problem, and it is something that the tools, like, you'd need to sort of do some of your own rigging to figure that out. But once you've done that, once you know what the twist value ought to be, you just plug it into these attributes.
Right. It also seems pretty specific to individual cases. It might be a little bit hard to figure out what to do generally in those cases.
Right. And we're most concerned in the deformer to doing the things that are most relevant in general, right? That are that the thing that falls out of your rigging primitive, as it were, right? The thing that just sort of comes naturally from it is the thing that you generally want, and that's going to sort of generally be the right thing in most cases. And there's always going to be special cases that you do have to handle in a special casey way. But what really bugs me about rigging technique is that in a lot of cases, everything's a special case. And everything being a special case is the thing I really, really don't like. And what that tends to lead to is super complex auto rigging systems. Because you get auto rigging systems that have to basically handle this like extremely complex, this extremely complex stuff where rigging systems are... you need to build the whole system to manage twist, right? You need to build all of this stuff to handle stretch. You need to have your auto rigger explicitly build all of that stuff. And it tends to end up being very special casey, where like you build it differently for arms and spines, and you do various sorts of things. And it's one of the reasons why auto rig systems have become so bloated, I think, in sort of over time. This is something that
Anyway, let's move on though.
Yes, let's move on. I've ranted about auto rig systems enough.
Yeah. So let's see. Do you have reasonable weights there, at least for the arm?
Yep. This will work. Let me mirror them.
So, yeah.
Yeah, stop that. Yeah, there we go. Reasonable weights there too now. So I don't want to go. I think we can go to around 5:30. I've got some other stuff to do, but that should let us handle like some more topics. What I was going to show next, I think, is layering some deformation on top. Because the kind of thing, especially for like, it's probably pretty evident that what I'm doing here is, intended to be like pretty cartoony, rigging. That's certainly not the only thing you can do with contour, but it's something I do a lot. So, that's sort of what comes naturally to me. And what that means is it's often really helpful to have a layer of tweakers. Little tweak controls that you're going to have around somewhere on your surface, and they're going to do tweak things. And they're going to let the animator have low-level control. And this is a pretty good example of how you would stack, use a generally applicable like Maya deformation technique that gets stacked on top of contour in a useful way. So the first thing I'm going to do there is I'm actually going to do something kind of weird. I'm actually going to topo this. Because what I want to create is I'm going to create a conventional skin cluster that's going to go on top of the contour cluster, inherit all of the deformation from it because it's going to be additive. And for that, I will need some basic weights. And the simplest way to generate the controls and also to actually transfer the weights onto this surface without doing a crazy amount of weight painting is actually to make a surface that I generate this thing from. And here's where I'm probably going to do some stuff. And again, like, I don't know exactly, like everyone who's watching this, right? For some people, this is probably all old hat. But, I'm going to do something that I haven't really done a lot yet in this particular stream, which is I'm going to do a lot of sort of ad hoc Python. Because my experience is, you want to rig some stuff, and a lot of the time you're going to be using some ad hoc Python, and that's going to include using the Contour API. The pre-deprecated API, as we say, and we're probably going to talk about why that is when we get to it.
Yeah. But yeah, it's worth mentioning there is an API to Contour stuff that lets you do, I think, most of the stuff that's really essential.
Yeah. I mean, certainly it'll let me do any of the stuff I'm trying to do here. I'm just going to close some of these. I'll open them again if I need to. So what I'm actually doing here is by using a retopo tools, it actually gives me a good way of making controls that are going to be on the surface. It's kind of like a weird purpose for retopo tools, but I find it actually to be pretty effective. Let me make sure I have symmetry on. Yeah, I want to do world X. Ooh, I see the problem. Haha. Yes, all right, 1 second. Got to do something else first. Yeah, this mesh is weird, and like I said, it's kind of old, and one of the things I realized just before we did this stream is it's inside out. So if I were to turn off two-sided lighting, oh look, that's actually the back half. It's a little silly. I don't really want to mess around with the mesh itself too much. I'm just going to duplicate it to do this, and hide everything else, and flip it. That'll work. It is, though, and the reason for that is when I modeled this, like I said, I modeled this a long time ago. I probably wouldn't do this today, but like it's basically like the surface comes up and around to form these lapels. It's probably not the best idea, actually. Anyway, right now I should be able to. No. That's the live surface there. Thank you. No, stop it. Apparently I gotta re-enter the tool to make this work properly. There we go. Yeah, so let's say we want a line of controls.
And thank you, by the way, Jessica, for that. Yeah, we don't have immediate plans to do anything with Blender. It is something that could happen in the future.
Yeah.
But yeah, we have a fair bit on our plate at the moment.
Yeah, that's pretty much what the situation is. We just have a lot to do. Let's see. Yeah, no, these should get, like, there we go. And so what I'm essentially doing here is I'm using this as a way of figuring out where I want some controls that are going to be on the surface. So maybe something like that. Really, it's going to mainly be, like, I might not have any controls down here. Actually, I might not need them because that's kind of where the belt is. But you might want some in here to, like, sort of shape his body. I mean, it's going to really depend on your character, and it's going to depend on your animators, and it's going to depend on what you want to do with your production. And, like, this is a very special Casey thing, But I think legitimately so. Also, sometimes it's a little awkward. But there we go. Because this really is, like, this is sort of legitimately special Casey. Because it's like, well, this really is very specific to what you need to shape this particular character. So, you want things to be special cases only where it's actually important for them to be special cases. And not where it isn't. All right, I am going to add some others here, which are not going to become controls, but are just going to be there for weight purposes. Is it going to let me? No, it's not. I'm going to have to position some of these after the fact. That's fine. And I'm gonna have to clean up some things, and like it's all gonna be okay. Actually, that's probably okay. That'll work. All right. So here's what I'm gonna do. Maybe I'll move these down a little bit. I don't know. I always think I'm done with something, and then I look at it again, and I say, no, maybe I should tweak that a little bit. Maybe I don't quite like where it is yet. Anyway, so here is I'm going to kill this duplicate that I only made because the normals were pointing in the wrong direction. And here's the mesh that I'm going to generate these controls off of. And now I'm going to write some like ad hoc Python. These are the ones that I'm going to want to become controls. The other ones are just sort of there to sort of relate to where the mesh is when I transfer weights. Thank you, script editor. Yeah, let me so I import I frequently import pymel.core as PA. I know that's super weird. Everyone's always confused by it. And when I write code for other people, I use PM because that's the standard. But
there's a reason. There's actually a historical reason for it. It has to do with pymel.all and pymel.core.
It does. And then I just got so used to it that it's what my fingers reflexively type. So this is what I do. Oh, you know what? That is a great point. I will save. All right. So I can get all the vertices. Let me make sure I'm actually getting all of them. Yeah, see, that's what I thought. It was hiding a bunch of them from us. And we actually do want to look at each vertex independently, because what we're going to do is I'm going to make a joint, and I also can't, apparently I can't type. I don't know what's going on. Think this'll work. Damn it, it's point something. I'm gonna have to look it up. I'll look up the PyML documentation. Mesh vertex. There's gonna be one here that's like the oh, it's get position, I think. Yeah, there it is. This is all equivalent to world space, so I don't have to worry about translating between spaces. Did that work properly? No, it didn't. It did not. It did it once and then failed. Now, why is that? I sure hope... Nah, it can't have been the CG blast panel, etc., screwing with it, because that usually is totally benign. Because it generated one of them and did the right thing and then stopped. I wonder if that actually is what's happening. I wonder if that's actually causing the script to stop evaluating. Actually, let's just check and make sure it didn't just... Oh, okay. No, it's actually that I did something really stupid. It made all the joints. They're just in, like, ridiculous positions, I expect. Like, where the heck are they?
Yeah, that panel up callback error. Really
that panel up callback error. The thing is, it's like, is this thing that I'm seeing here a real error? Oh. Yeah, okay. No, it actually worked perfectly well. I was just hiding a bunch of that stuff, right? That was very silly. No, it's actually fine. These are all in the right place. Just to be clear, if anybody here was under the impression that people who are extremely experienced with Maya don't make silly mistakes, the answer is no. We actually make silly mistakes constantly, essentially all the time, without ever stopping.
Yeah. So it might be worth just like going back over what you've done here, Raph.
Right. So here's what I've done. I created this mesh that I'm going to use to figure out where the position of my tweaker controls are going to go. And using like a simple little bit of ad hoc Python, I generated a bunch of joints at the position of each of these vertices that I are going to turn into like where my tweaker controls are going to be. Now I'm going to use this as a way of essentially transferring, creating some weights that I can transfer to a contour deforming skin cluster, but to a regular skin cluster that's going to go on top of the contour skin cluster and give me these tweak controls.
And this
So
is a pretty general technique. You
it
don't
is.
have to use this just with contour.
That's right. You
Right?
don't.
Like,
You don't. This is just an example of how you could use some general Maya techniques and just sort of like stick them on top of contour, and everything works fine. So I'm also going to generate a control for each of these things. And as you may know, like I'm not naming this stuff as I go because I'm trying to do it pretty quickly. I mean, you probably shouldn't. My opinion is that naming in rigs doesn't matter as much as people tend to think, but that's true of dependency DG nodes. DAG nodes, you probably should name something reasonable that people actually can make some sense of. But right now I'm not, because I'm being like, I'm just like, right this second for demonstration purposes, I don't care.
yes, and as Isai Calderon says, even monkeys fall from trees. And it's
Right.
worth noting that Raph likes monkeys.
Well, sure. I mean, who doesn't like monkeys? Like, monkeys are cool. They move in a ways that are cool. And I've been animated,
In fact,
so I like that.
you might notice that our webpage, the thing at the very top of it is in fact a monkey.
That's true. Although that monkey was not my idea. That was done for a studio, a Vietnamese studio called Ventana. Let's see, a circle. Pretty sure I'm gonna have to. Yeah, the transform node's gonna be the first thing it returns to me. So I am creating a buffer for this circle. Now, of course, Maya now has parent offset matrix, and arguably, I happen to be using Maya 2020 now. I don't remember if Maya 2020 has parent offset matrix, but yeah, you can avoid buffers in some cases. I have a habit of continuing to do them because a lot of the work that I do ends up using older versions of Maya, or it has to be compatible with older versions of Maya. So even though parent offset matrix would allow me to avoid having to create an extra buffer transform, I usually end up doing it anyway, because if I ever want this to work with an older version of Maya, it's going to have to be. And to make that clear, because again, this is something that I'm sure lots of people understand perfectly well, but some people watching the stream these might be new concepts. The idea there is to essentially make the default position of that control be where it is when you zero it. So you make its parent space something that is in a transformation that you want it to return to when zeroed. And that's built into transform nodes in Maya 2022 and maybe Maya 2020, I don't recall. But it isn't in prior versions of Maya. So you have to end up creating this extra transform. I actually do have library code for this, but I'm not using it right now because I think it would be instructive to just do it out by hand. And also because I don't actually know if I happen to have it like on this machine. I'm actually in the process of transitioning machines a bit. Anyway, let's set parents. Again, all of this stuff is going to work because everything's in world space right now. I would have to account for explicitly getting things in world space to make them line up properly if that were not the case. But it is. Oh yeah, and then also, once you've transitioned it, so now I have some controls that move the joints around and are in the position of the joint. For anyone who isn't as familiar with this, which, like I said, plenty of people watching this is probably not surprised, but for anyone who sort of isn't really familiar with this approach to rigging, part of the reason it's important to have this stack of things, or the reason why you'd want to just sort of attach your joints to a control, is to create a separation there. So if you ever needed to offset the joint, right, you'd be able to you could do that. It's just parented to the control. It's actually pretty reasonable to use joints directly as controls under some circumstances, and maybe I should have done it in this case, but I didn't. I'm in the habit of doing it this other way. In addition to which, it's worth noting that this would have been a huge pain to do by hand. So even though like writing a script, occasionally like this all went fine and it worked the first time. A lot of the time scripts don't. A lot of the time scripts are really obnoxious, but sometimes they do. And even if they are obnoxious, you still should do this sort of thing with a script because it would be incredibly painful to do this all by hand. And PyMel makes that reasonably easy. I'm not always happy with PyMel, but it's great for stuff like this. Anyway, I'm now going to select all of these controls. Of course, now that's kind of a pain. Um, do I want to just go select them by hand? I could just query the scene for them. Yeah, they're the only joints in the scene. Actually, I don't even remember what this menu option is, because I'm in the habit of doing it this way too.
Yeah, I absolutely would have done that.
Yeah, exactly. It's
With
like
Python.
yeah, no, I mean
But yeah.
Python one-liners make things pretty easy. Oh, right, there's one more thing I need to do. I need to make a base joint, which again, because
Yeah, it's
you need something for where the other things aren't, right? And then we're just going to apply a regular old skeletal deformer on top of our contour deformer. Or actually, no, we're not going to do it to the contour deformer. We're going to do it. We're actually doing it first to. Yep, doing it first to the base mesh here that we're going to be transferring weights from. And this is a regular old Maya bind. This is all fine. And what that means is, at any of the points where a joint is specifically, you're going to get full weight at that point. So you don't really need to weight that stuff. But then, of course, you don't elsewhere. So here's one of the things I need to do here. Using regular Maya weight painting, it's that I need to take... what the heck did I call it? Is it joint 11? I don't remember. What is it? Oh, it's joint 12. I didn't add it, apparently. Or it decided to unadd itself. That's fine. I'll add it now. And so now what I should be able to do is I want to take all of this stuff and any of the bits that don't have a joint that goes with them that I just made, and I want to make that be directly weighted to the base joint there. Because that stuff should not move around. I mean, the contour deformer is going to move it underneath, but that stuff should not move around relative to these other joint controls. That should be stationary. Let's just make sure this actually worked properly. Pretty sure it did. Yeah, that's fine. I've only got the one thing. All right. Now I'm going to actually parent them, or rather, not parent them. I'm going to actually bind them to the body and create a skin cluster on top of our contour deformer. Yeah, probably this is why that didn't work. Let's just make sure that this is all vaguely appropriate. It seems like it is. Although, actually, yeah, what am I thinking? Max influences really should be 8. As far as I'm concerned, 8 is the smallest number of max influences that it's ever reasonable. It has pissed me off for a long time that game engines ever considered 4 to be viable. So as you can see, this is, a bit of a disaster, right? Like the default weighting is going to move the arms around and all kinds of other stuff, which is why we're going to transfer from here. We'll still have to fix a few things, but it'll make that a lot easier. Might as well make it 1-to-1 and just be extremely explicit about what joints we're actually transferring for here. And so what we should get now is that, yeah, we're influencing like this very specific part of the mesh. But, it's pretty much going to go back to true, as it were. At this point, where it meets the belt. And we are going to have to actually fix something here. I mean, it is going a little further than it should, but we'll get to that in a second. But first, we don't really need that anymore. It's done its work. And the thing that I really want to make sure of is that none of these things are going to affect the arms or anything else that they shouldn't be affecting. And again, I really should have named that joint something so that it was more clear on the stream. This is a bad habit of mine.
Right. And again, we see something that is kind of nice, which is this is painting some weights, but they're pretty easy weights to
Right.
paint.
Yeah, this technique doesn't necessarily require like extremely careful weight painting. Um, Although I am probably going to have to smooth some of this stuff out a little bit. I mean, we'll get to that part where we refine it a little bit, shortly. The main thing that we want to get out of this is that these controls can be used, and like the exact amount of fall off is like, oh, we can figure out what that needs to be. It may not be exactly what we want, but these can be used to tweak the shape, right? An animator could come in and be like, no, I really want to. Now I'm selecting the wrong thing. I really want to like have this pressed in here, and they have a way of doing that. And that's what those controls are for. They do need a little refinement. Now, of course, the problem we're going to get here. So unlike multiple skin clusters, like Maya doesn't like you to stack skin clusters on skin clusters, like conventional Maya ones. There's no real actual reason for that specifically. It's mainly because they thought people were going to be confused because they would be getting double transformation, which of course is exactly what's going to happen. So if I do this. Well, actually, if I do this, nothing happens because I haven't actually constrained any of these yet. I kind of forgot that part. Let me do that first. So I am going to actually, we want these to follow along with the surface. And the easiest way to do that is going to be to use the contour deform field constraint. The deform field constraint is basically something that pushes transforms around as if they were actually deforming aspects of the mesh. So the same way that it deforms a surface, it would deform, quote unquote, the transform. And it's because
and it's worth noting that the deform field constraint is actually, in some ways, it's kind of the soul of rig tools. I mean,
yeah, actually,
the splines kind of are, but the constraint, we knew it was important when we wrote the constraint. We knew we'd have to have this constraint, but it's always been a little bit of a surprise to me just how central it is to working with contour. The constraint allows you to do a lot of things.
Right, and it allows you to do a lot of things relatively easily that otherwise would require like Doritos. Like I don't know if people have heard that term, but that's like when you make a polygon and you deform the polygon and it exists only to have a follicle on it so that you can put a transform on it. And like Doritos are like a huge pain and add a lot of complexity to your rig, and it's very nice to have something that will just push the transform around by the deform field, just like the mesh is, and not have to worry about any of that stuff.
Right. So we have a couple of constraints, but the deform field constraint is the really important one. And what it does is it deforms a transform kind of as if it were a vertex in a mesh, but it also gives it a reasonable frame. And what that kind of means is that, for instance, if you were to bind a button, you were to take a button and deform field constrain it. If that button started off sort of tangent to the surface that you were deforming, it would remain so as you moved the spline around. So it would stay on the surface, but it would also get a frame that kept like a normal pointing out of the surface. And the deform field constraint comes up everywhere.
Right. And so in this case, this is double transforming now, just so we can see, I mean, we're going to fix that in a second, but just so we can see this transform moving as it should. I'm going to turn off the skin cluster so that the double transformation doesn't happen. And now you can see, yeah, this thing's moving around with the surface just as if it were being deformed. Now, part of the thing here is if we had to do this manually for all of those would be a huge pain. So I'm going to write a little script to do it. I'm just going to like first be like, I think it's contour lib dot pre-deprecated API. I'm actually not sure about that. That might actually be wrong. Yeah, it is wrong. I think it might be that actually. Yeah, that's what it was. Oh, right. Also, I don't really want to type that each time. There we go. I think it's create deform field constraint. Yeah, let me look this up. I don't necessarily remember completely off the top of my head.
Yeah, take a look at the docs. We have pretty good docs for the API. So I won't weigh in. I'll let you take a look.
Right. The one we want is create deform field constraint. I was right about that. That is actually exactly what it is. And we're going to give it the socket, which we previously just stored in a variable. And then we're going to say so pretty simple use of the API, but pretty helpful actually. And so here now we've got them all sort of moving around with the surface. But of course, now we have to solve the double transformation problem. Because if we were to turn the skin cluster back on, whoops, I also moved it way too far than I intended. Yeah, all right, here's some ugly double transformation. Oh, also, let me mirror the weights because I fixed them over here and not over there. There we go. But, obviously, double transformation looks all kinds of weird. So here is a thing that is actually, I think, there are certainly people who use this technique, but I actually tend to feel that it is not particularly well understood among, even people who do a fair amount of rigging, which is that you can control the bind matrix of a skin cluster, of a particular joint that's contributing to a skin cluster really directly. So let me actually show you what I mean by that. So if we actually, here, let me just get everything this skin cluster is going out to. It's actually going out to multiple skin clusters. Which one is this one? This is skin cluster 2. All right. The world matrix of this joint is going out into one of the input matrices that go into the skin cluster. But that is not the only place where matrices are stored. There's also pre-bind matrices, which actually do not seem to be showing up here because not every attribute you necessarily have on something always shows up in the node editor. Yeah, that's not it. Is it just pre-bind matrix? No. Also, you can't see anything. It's not called pre-bind matrix. Maybe it's bind pre-matrix. I can look this up, but no, it's not. Sorry, I have library code that does this, so I haven't done it by hand for a while. You know what? Oh, because never mind.
Matthias is giving you a comment here that looks pretty useful. He's saying right-click show all and then search.
You know what? That's because I'm so used to doing stuff with code that I often don't do that stuff. But anyway, I also figured out what my issue was. I was trying to do that stuff on a list because of course pa.selected returns a list, not
yes.
I didn't get the first item. Yeah, that's what it is. I actually knew, but anyway, if you put it into the bind pre matrix. So you've got this matrix attribute, this matrix array, which has all of these incoming matrices. At the same index, you have a bind pre matrix, which is that's actually the bind data. That's actually where the bind data of the skin cluster actually lives. Like people sort of have this idea that it lives on the bind pose, but all the bind pose actually does is to tell you what pose you can return to, which of course hardly ever matters because you're probably driving your joints with something else. So in a conventional Maya rig. So like bind pose barely does anything. This is where the actual bind data for joints lives. And that way we can actually literally drive it. So one of the ways that we could do this here, let me just store some stuff. I'm going to get the skin cluster and store it. And then I'm going to go get all these joints. Yeah, no, I'm not. And then I'm just going to remove joint 12 because this won't apply to that one. That's the base joint. And I'm going to write another little snippet of Python. Yeah. I'm going to say joint.get parent, because remember, it's the buffer that's actually being moved around that we want to be. Essentially, the difference between the buffer and the joint is what we want to produce our deformation. And this concept of like the difference between two things produces deformation is actually really important. But something that Maya kind of tries to hide from you, which I think is actually kind of destructive. I wish Maya didn't try to pretend that that wasn't what was happening all the time. Get the first world matrix, which the reason why that's an array is because of instancing. We know we never care. We always use the first one. And we want to put that into our skin cluster dot bind. Was it pre-bind matrix or bind pre-matrix? I never freaking remember. It's bind pre-matrix.
Yeah.
We need to know what the index of the joint is actually in the skin cluster. That's right. One second. Yeah, actually, I'm going to do this a different way. I'm actually going to start from the skin cluster, because I should be able to say let's see. That probably will give me. Aha, yes, that is the. So I can just loop through these inputs and know what index we actually have here. We just need to know how many joints there are. Yeah, I wish I remembered that. Here. One less than this, or actually just this number. There's 11 of them. Let's do this. Let's just make sure this is giving me the values I think it will. It totally is. Let's make sure I'm getting the right thing. Yep, there. Oh, I put 1 in there instead of I. That's what's going on. Yeah, there we go. There's all the joints, but also now I have the index that they go with, which is the important bit. So I'm going to take that joint, and I'm going to take its world. Now I get its parents. What the? I hit something, and Windows really thought I wanted a pop-up, apparently. Oh, no, it's world matrix. And I'm gonna, can't type. I'm gonna plug that into also the skin cluster dot bind pre-matrix I. Let's see if this works. Actually, let me save first. Oh, looks like I might have already done so, but anyway. Clearly it did not work.
So what's up?
And now it's all just broken. Okay. This is the rigging life, people. Oops.
Yeah, the dangers of being live.
Yeah, the dangers of being live. Well, unfortunately, I think we have come to. I'm gonna end this one on a cliffhanger, because now it's past 5:30 and I've got other stuff I have to do. So we will solve this issue, which I'm pretty sure is just me doing something dumb. In like a second. Oh yeah, no, that's it. Sorry, Matthias Roivik knows what's going on. Yeah, I needed to do the inverse matrix. That's what the issue was. All right, let me actually do that real quick, because then we can see this working. Is that because I just reloaded? Or something? Because Skin Cluster 2 sure ought to exist. Yeah, it totally does. Something broke the that particular Pi node. Where was I? I was taking a look at the node editor, where it sure, yeah, I mean, that pretty clearly does exist, doesn't it?
So I missed a little bit of what you were doing, but are you trying to use a variable that you stored it in before reloading the scene? Because that's probably not going to work, right? It hangs on.
Right. No, that's exactly what I'm saying. That's like I'm pretty sure that what happened here is that I've now got a pi node that's pointing nowhere. So I'm just going to actually, you know what? I'm gonna say skin cluster equals to make sure that I do have a current. Yep, I do. That works. I've got it. Let's try it now. Did this work? It looks like it did. And now I've got controllers that essentially allow, follow the contour deformation and allow you to have extra additive control on top. And actually, like, the weighting of these controllers is a little weird, which is why this is a little wiggly. And so, it probably would make sense to clean that up. But generally speaking, this is a really useful technique that makes use of contours deform field constraint in a way that I often find extremely useful. So that's layered deformation being done on top of a contour deformer. And that is where we are going to end it for today. I think I am obligated as a streamer now. I mean, because I'm a YouTuber, right? I have to say like and subscribe at least 10,000 times.
At least 10,000.
So you're
also
to recap.
Yeah. To recap, I mean, thank you all very much for coming by. We're going to be doing this every week. And this week, we showed a little bit of contour. We spent quite a bit of the time as well, just talking about other general techniques. And I think that that'll be a little bit of something ongoing. We may delve a little bit more deeply into the contour stuff next time. I think have a little bit more of a focus on that. And we'd like to show off the ephemeral tools at some point too. But we're also going to be hopefully mixing in a fair bit of stuff that's useful, even if you're not using our tools. So we hope you'll come back.
Absolutely. And I think there's just an enormous amount of stuff to explore here. Right? Like, that is to say, there's so much of the philosophy kind of like of animation and rigging under this. There's so much there's such a broad range of techniques. Like, I actually think this is going to be a much more effective way of getting this across in some ways than me writing a lot of blog posts are, because it takes a long time to write a good blog post. And come up with good demos and come up with good little snippets of stuff. Streaming is a lot more material to go through, but it has the advantage of it's kind of okay if you kind of screw it up a little bit on the way and you can talk to people. And I think this is actually going to be really nice in terms of, getting across some of these ideas that I feel are really important.
I think so too. And, thank you very much for putting up with us. We're not, as you can probably tell, we're not particularly seasoned streamers. So, apologies for us figuring this out as we go. Hopefully we'll get better at it.
Yep. And we'll have this up for other people to look at, and also probably some selects from it. I don't really know exactly how that works in YouTube, but we're about to find out.
Yep. Okay. All right. Well, thank you very much for coming. And I guess as Raph said, I have to say like and subscribe a lot. So
that's right. Like and subscribe. Yeah, do that.
We hope to see you next time.
Yep.
All right. Thanks.
All right,
Bye-bye.
Bye.